Welcome back. Let's do question number 6 now. Figure Q6 shows an image and a grid. Compute the histogram and show graphically. So now you can notice that in this one the maximum intensity is 7. So it is a 3-bit image. So we can sketch the histogram. Intensity values for 0, 1, 2, 3, 4, 5 and 6. So now it's a counting business. Fix intensity 0. Okay, 0. Yeah. Use a different color. This one. Yes, 0, 1, 2, 3, 4. 4 zeros. Then pixels with intensity 1. Light blue. 1, 2, 3, 4, 5, 6, 7. Then pixels with intensity 2. 1, 2, 3, 4, 5, 6. I hope that's correct. 6. Then pixels with intensity 3. 1, 2, 3, 4, 5, 6, 7, 8. 8. The next one is pixels with intensity 4. 1, 2, 3, 4, 5, 6. What way of marking? 6. Then intensity 7. 7, 2, 3, 4. Yeah, 4. Forgot the ones in between. Intensity 5, 1, 2, 3, 4, 5, 6, 7. Now with intensity which color? I don't know. Intensity 6. 2, 3, 4, 5, 6. 6. So let's add them up and see whether you get the size of the image. Now image size is 1, 2, 3, 4, 5, 6, 7, 8. 8 times 1, 2, 3, 4, 5, 6, 6. So you must get 8 times 6, 48. So 4 plus 6 is 10, 7 plus 8 is 15, so that's 25 for this. Then 6 plus 4 is 10, 7 plus 6 is 13. We didn't get it. So there must be something wrong. So It's wrong. 6. It is correct. It is correct. This addition is 23. Correct. Okay, so we get 48. So histogram is correct. So now compute the histogram and show graphically. So this is what you need to show here. And then carry out histogram equalization and show the result in the grid shown in figure Q1b. Okay, for the histogram equalization you need to build a table. So K input intensity 0, 1, 2, 3, 4, 5, 6, 7. Then NK number of pixels with that intensity. So we can write 4, 7, 6, 8, 6, 7, 6, 4. Then we have to get the cumulative sum of NK, and then we have to do L minus 1 times Mn summation NK. The Mn is 48. Size of the image, L is actually 8. L minus 1 is 7. L is the number of different values that a pixel can take. So they are from 0 to 7. That means 8. So L minus 1 is 7. So you have to multiply the whole thing by 7048. So this number is actually 7048. So then you have to round. Okay, summation of NK, then means cumulative sum. 4 plus 7 is 11, 11 plus 6 is 17, 17 plus 8 is 25, 25 plus 6 is 31, 31 plus 7 is 38, 38 plus 6 is 44, 44 plus 4 is 40. So you must get 48 here. So now take each of these numbers and multiply by 7 divided by 48 times 4. So now each of these numbers, like 4, get 0.58. So approximate value is nearest integer is 1 here. So next value would be 11. 1.6. I will not write the expression 1.60. So that is approximately equal to 2. That's 1, that's 2. Then 17 multiplied by this number, you get 2.48 is equal to approximately 2. Now 25 multiplied by that number 7048, 3.6465 actually. So you get 4 here. Then 31 times that number, you get 4.52. That's approximately 4. Then 38 times that number, 5.54. that is approximately equal to, let's, I don't know, 6. Then you have 44 multiplied by that number, that means 6.41, approximately equal to 6. Then finally 48 multiplied by that number, you get 7. Okay, so now what this means is, whenever you have 0 in the input image, you put 1 there. When you have 1, you put 2 there. When you have 2, you put 2 there, and so on. When you have 3, you put 4 there. Okay. For all zeros, let's put 1. For all zeros, let's put 1. Yeah. Then for all ones, let's put 2. For all ones, let's put 2, 2, 2, 2, 2, 2, 2. For the others, I'll use the same color. For all 2's, let's put 2. So 2, 2, 2, 2, 2, 2. Right. For all 3's, let's put 4. 3's, 4, 4, 4, 4, 4, 4, 4, 4. For all 4's, let's put 4. Then for all 5's, let's put 6. I hope I'm doing it right. For all 6's, let's put 6. For all 7's, let's put 7. That's histogram equalization. That's the answer for this, but you put the answer on the grid. Then question 7 is, compute a 5 by 5 Gaussian kernel with sigma equals 1. So let's do this by drawing the grid first for the 5 by 5 Gaussian kernel. Okay, so see, now when you compute the kernel, you have to consider this as 0 and this as 0. 1, 2, minus 1, minus 2, like that. Indexing. So the thing is, we have to write the expression of the two-dimensional Gaussian, but let's not write the constant that is in front. So let's just call it gxy equals no constant, because we are anyways going to divide this by constant to make the value sum to 1. Or should we do it? Anyway, e to the power of minus x squared plus y squared divided by 2 sigma squared. What is the constant in front? That we will actually decide to write down all the numbers, sum them up, and divide by that number. So that part I may not do. So first at 0, 0, g0, 0, e to the power of minus 0, so sigma is equal to 1. So e to the power of 0 is 1. Then you have G. Let's consider this location, for example, 0, 1. So e to the power of minus 1 divided by 2. Okay, let me properly write that. E to the power of minus 0 squared plus 1 squared divided by 2 times 1. That is e to the power of minus 0.5. So you can see for this location, this location, this location, and this location, for all four you get the same value because it's just one index here. So you notice that if you just briefly think about it. So sorry. So let me do this computation. E to the power of minus 0.5, that's 0.606. 5. I hope you see why all these four numbers get the same thing. Now let's consider a location like this. Oh, it's easy to consider this one, right? Also consider a location like this, 1 and 1. So G 1 1. For this you will have e to the power of minus 1 squared plus 1 squared divided by 2 e to the power of minus 1. That one would be 367.3679. This one is okay. Then if you take a location like this, once again one index is 0, the other index is 2, so therefore you will get e to the power of 1. So for example, take 2 0. Same number. Okay, now let's consider a location like this, 2 and 1. Uh, 5 divided by 2 e to the power of minus 2.5, 0.0821. And finally you have only 4 numbers to be put. G22, 2 squared plus 2 squared divided by 2. That means e to the power of minus 4. You would get 0.0183 So okay, now this is not done, so there is something to be done. So let's call this k. You have to take k and divide by sum of k, this full sum of that. That's the final answer. You have to write another grid of the same size, where you put this sum. So I will not try to do that sum now, because I'm using a calculator. Because in image filtering like this, when you sum a kernel, it must turn out to be 1. So if you take an averaging kernel of 3 by 3 averaging kernel, see, we have 1 1 1 1 1 1 1 1 1 all 1, so divide by 9, like that. Okay, next one. Figure Q8 shows 3 by 4 image and a filter kernel. Filter the image using this kernel. Only consider the positions where the kernel fully overlaps with the image. So kernel has to fully overlap with the image. There are only how many locations? 2 locations like this. So this can be one center, this can be another center. Otherwise the kernel will not fully overlap. Okay, let me call this A. Let me write the answer for A. So that would be, so now we locate the window in this fashion, kernel in this fashion, and then this element gets multiplied by that, this element gets multiplied by that, and so on. So let's write this. $87 times 0.0751 plus 110 times 0.1238. Let me need more space. One hundred 10 times 0.1238 plus 101 times 0.0751 plus 68 times 0.1238, that means this number and this number, plus 127 times 1.2042 plus 91 times 0.1238 plus, then take this number 20 and this one, 20 times 0.0751 plus 37 times 0.1238. You multiply the corresponding locations. 23 times 0.0751. So you got to write the answer for that. So next one, let's write a few things for B. This is B. So there, the window is this one. That's the window. So we have 110, 101, 75, 127, 91, 43, 37, 23, 11. So this multiplied by 0.0751 plus 110 multiplied 0.1238 plus 75 multiplied by 0.0751, and so on. So this multiplied by 0.1238, 91 multiplied by 1.2042, and so on. and then you have to sum them up and write the answer. Okay. Question number 9. Figure Q9 shows an image and a kernel. In this image, all the pixels are 0 except the two that are specifically indicated in the figure. So all are 0, only these two are there. What do you expect this kernel to do when used in filtering? So when you use this in filtering, you see when the now center of the kernel is this one. When the center of the kernel is here, this number multiplies with 255. So like that. So the kernel gets located at this place because the kernel is symmetric. So the values of the kernel gets located with the center at locations with intensity 255, of course multiplied by 255. So just multiply and put. So for example, that's the center. So for this one you will get 0.0751 multiplied by 255. For this one you get the center of the kernel 0.2042 multiplied by 255. That's what happens. Filter the image using this kernel and show the result in the image. So this is what you need to do. You compute these numbers and put as there. So as a result you will get values only for these locations. Due to this 255 over here you get these numbers. Due to this 255 over here you get these numbers. All others remain to be 0. So I will not do this computation, it's quite easy. Question number 10, the last one. 5 times 8 image and a kernel are shown in figure Q10. The center of the kernel is indicated by this one. Carry out median filtering on the image using kernel to generate a 3 by 8 image. So you see the kernel can first be located here with the center over there. It cannot be located otherwise. So median means you pick the middle value. You pick the middle value. So now when you locate the kernel, you have 145, 163 and 200. 145, 163 and 200. So order them. Now it's already ordered. Pick the middle value. 163. Okay. Now locate the kernel over here. So values are 76, 194 and 164, and order. You have to order them. When you order them, you get 76, 164 and 194. Pick the middle, 164. Okay. So now you can just look at it and do it. 150 here, 150, 190, 153. Middle one is 150. For the next one, 2140, you get 4 here. 183, 170, 84, 170, 154, 103, 95. When you look at it here, the middle one is 103, 102. Here the middle one would be 162. And then the locations of kernels in the next row. When the kernel is located over here, so the middle value is 163, 163, 153. Middle value would be 4. In this one, middle value would be 170, 103, 102, then finally in this one 162. Then locate the kernel over here, that's the center. Then the middle value of that would be 195 when you order them, then 180, 153, 0, because 0, 68 and 0. Then he would get 195, he would get 95, 134, and then 83. That's the median filtered one. By observing the result, identify the special property of this median filtering kernel. So this median filtering kernel, because it is like a kernel like this, it does not average, it does not do median filtering horizontally but vertically. So it is a kind of a vertical edge preserved median filtering. So you see that this is kind of vertical edge here that has been preserved. So if you had a median kernel of this nature, then horizontally and vertically it will do the median. Now here in this case, median will be done only vertically. So vertical edge preserving median filtering. Okay, thank you.